Okay, so for this partial project of Calculus 2, we're going to solve the problem 7 of the given lab, which consists in a word problem that says that the range of a projectile is given by the following equation, where v is the initial velocity in feet per second, and theta is the angle of elevation. V0 equals 2,500 feet per second, and they are giving us the two datas, which is data 1 is 10 and the data 2 is 11. So the first question of this problem is A. Determine the change in the range of the projectile. So they're giving us the V0, so we're going to substitute on the formula. And we're also going to substitute the data 2 in the sign. So in here in the sign you have, in the trigonometric function, we have 2. So it's going to double the value of the data. So we're going to insert data 2, which is 11. 11 by 2, 22. And then we're going to get the result in the calculator. So the answer of this operation is 73,165.3503. And then we're going to solve the first data, which is 10, using the same formula. So we're going to substitute multiplying by 2 because we have a 2 in the trigonometric function, and it's going to be 20. And the answer will be 66,800.8092. Since they're asking us for the change in the range, we're going to use a formula given in class known as increment. So the formula of increment is delta y equals f of x2 minus f of x1. So in this case, the f of x2 is represented by the operation that we substitute data 2, and the f of x1 is represented by the operation that we substitute data 1. So now we're going to subtract the results. It's very important to write the proper notation in this type of problems. So our f of x2 is the first answer that we got by substituting. And then we're going to substitute the f of x1 with this answer. So if we do this subtraction in a calculator, it's going to be delta y equals 6,364.54.
Okay, so in the part B of this question number 7, they're asking us for use differentials to approximate the change in the range. So we're gonna get the differential, the approximate by differential, which would be dy equals f prime of x dx. So as Octavio said, they give us the value of V0, and we're going to substitute it in the original equation to get the original function. So r equals 1,500 squared over 32 sine the angle theta. Okay, so if you plug this into the calculator, you will get 195,312.5. And then you continue with sine of 2 theta. Then we're gonna differentiate this formula to get the derivative, which would be we're going to put this with an f of x equals volume, and f prime of x will be, the derivative of sine will be, if you get your formulary, be able to see that when you differentiate sine, the derivative of sine will be cosine u prime cosine times u. So you would have this original number of the equation times cosine of u, which is 2 theta, times u prime of your trigonometric function, which will be 2, because the prime of 2 theta will be 2. So your final differentiated function, or your derivative, will be, okay, so it will be 390,625 cosine with the angle of 2 theta. Then, already having your f prime, you will substitute this equation into your original equation you want to solve. So you will get dy equals the volume times dx. So then, what do you have to do? Okay. So from here now, the only value you're missing is a dx. So from the problem, we get that x1 or theta 1 is equal to 10 and x2 is equal to 11 degrees. So we know that dx is the same as x2 minus x1. So in this case, dx will be 11 degrees minus 10 degrees, which will leave us with dx is the same as 1 degree. So you plug it into your equation. You have dy 190,625 cosine of 2 theta times 1, and you'll get the same answer that you had. Doesn't change at all. 25 cosine 2 theta. And this is your final approximate differentiation, which will be dy equals 390,625 cosine 2 of theta.
Okay, so now that we have the results, we're going to get to the conclusion questions, and the number of the letter C is interpret your results within the context of the situation. So we conclude that the range is bigger when you use the angle of 11 than when you use it with the angle of 10.
It's better to use the approximate change when you're talking about time that doesn't really matter. It's not really important if you're a little late or a little early. You only want to get an approximation about time or an approximation about range, but it's not actually a circumstance of very big importance. It's really important, it's better to calculate the actual change when you're talking about, for example, locations, and you need to send, a determinate object to a specific location, to a specific place or a specific position. For example, if I want to send a gift to my friend, which lives over here, I need to calculate the actual range of distance between me and her to be able to send the gift to the accurate home. Because if I get an approximation, I might be able to send it to, and you might say a gift is not that important, but maybe when you're talking about missiles or when you're talking about a public safety matter, well, it's important to calculate the actual thing. Okay, so this is problem number 27, which is the integration of 8 dx over 3 parentheses 1 minus 4x to the fifth power. So the first thing you have to do is to figure out what your u is. In this case, it is this, the numbers that are inside the parentheses, which are 1 minus 4x. Then you have to find your du. It will be the derivation of this, which will be minus 4. And then you have to find your dx. And this times dx. And dx is du over negative 4. So then you have to rewrite. You have the 8 over the 3. And then you have the u, but it has a minus 5 because you have to pass the 5 to the top. And then times dx, but in this case it will already be du over negative 4. Okay, so now you have to combine this, which will be 8 over negative 12, which simplifies to negative 2 over 3, u to a negative 5. The next step is to integrate this. So you will add 1, which will be negative 4. And then you have to pass this one to the bottom. So we will have 2 over negative 12, which will end up being positive, u to the negative 4. So this will simplify to 1 over 6, which will be like this, and you cannot have a negative exponent, so we will pass it to the other side, like this, plus c. And then you have to replace the u with your u. So to 1 over 6, and then u 1 minus 4x to the fourth power plus c. All of these equals the proper notation, which is f of x dx.